Hello and welcome. This video shows you how to use Houdini Knit Solver digital asset, and if you open the same file that you can download it along with the digital asset from the link in the description, you will have a network like this. And basically I've provided three types of knits and three types of unit cells for you to work and to connect them to the digital asset. So as you can see, what this digital asset does is to cover the surface of the input geometry using these unit cells. The most important thing that you should know is that the final result highly depends on the topology of the input geometry. Usually you will have the best results if your input geometry has quadrilateral topology. So here is a simple example. As you can see, I have the digital asset here. The first input is the geometry and the second input is the knit cell or the unit cells. And in this example I'm going to connect this switch node to the second input and a simple grid. As you can see here, it has very clean and simple topology, and also it is quadrilateral. So let me connect it to the first input, and here you can see right away the good result for this simple geometry. And of course here you can modify the size of the final texture using the resolution parameter. So if I increase the parameter, you can see I will have much finer and much smaller texture. Okay, you can refine your final texture using this parameter, or you can increase the division of the input geometry, and as I told you before, it's highly depends on the topology of the input geometry. So for example, if I increase the divisions to 50 by 50, as you can see, also here in this case I have fine texture for the output result. And it is very important for the more complicated geometries to increase the resolution of the final unit cells and the final texture, or increase the divisions of the input geometry to cover the surface as much as possible. So here, for example, let me choose the default values for the divisions, and here let me connect it to a mountain node so I can have a more complicated object. So let's increase, actually let me choose a good value for the height, and here let's see the result. And as you can see here, you can see some discontinuity between two adjacent unit cells, and that's because there is a sharp change between the orientation and the topology of two adjacent faces. Okay, so here what I can do is, as I told you before, you can increase the division of the grid, or you can decrease the resolution of the final output. Or the other thing that you can do is, for example, using a node like subdivide node to prevent any possible sharp changes between the two faces. So for example, if I add a subdivide node after the mountain, and you can see I will have much better results. The other trick that you can use is the fuse node. For example, if I create a fuse node here, and here for example you can see I have N1 and N2 groups, and if you come and see here this node, this merge node, and if I create a delete node, you can see which points are belong to the N1 and which points are belong to the N2 group. So as you can see, this point and this point, and also this point and this point are belongs to the N1. And basically, as you can see here, this point will be connected to this point of the adjacent unit cell, and both of them are in the same group. So same thing happens for the N2 group. So here you can see the points in the N2 group. This point will be connected to this point of the adjacent unit cell. Okay, so let's see here, for example, there is a small gap between these three unit cells. So let me enable the fuse node and let's increase the distance. Oops, it's too much, so 6 is enough. Okay, as you can see now we have connected unit cells. Okay, and please note that you will have the best result if you can apply the deformation after using this node. So as you can see here, let me decrease the height and let's decrease the frequency. As you can see here, in this case I will have better results. Okay, as you can see, the results after using the mountain after the digital asset is much cleaner than before. For the next example, let's try to connect it to a box, and here let me increase the size, and the same as before, let's create some divisions on the faces. Okay, so let's choose a number like 15 by 15 by 15. Okay, let's see the result. And as you can see, the result is good as we expected, because the topology of the input geometry is good, so we'll have the nice result. As you can see here, this input box has the quadrilateral topology, so let's see what happened if I add a divide node and make some triangulated faces. So let's see the result, and as you can see here, the result is not what we expected. Here you have two options. The first one is to go back and retopo your geometry and create a new geometry, or using a node like topo build to correct the topology of the input geometry. Or here there is an option, retopo. It tries to create a retopo geometry automatically, so let's enable this option, and you can see the result. In this case, because it is a box, it's the simple geometry, so the result is very nice, and this is what we expected. And it tries to correct the topology of the input geometry automatically, so usually you have a good result using this option. If you are using the retopo option, you can use the cell size parameter along with the resolution to control the size of the final texture. So for example, if I increase the cell size, I will have bigger texture. Okay, or maybe 20. Okay, as you can see, the result is very good. Okay, let's disconnect this box and let's turn off the retopo option, and in this example let's use one of these test geometry, and for faster feedback let me delete every part and just keep the main body of this geometry. So let's delete the unnecessary parts. Okay, now we have just the main body, and let's connect it to the first input of the digital asset. Here you can see the result, and if I zoom in, you can see you will have a good result. But what happened if I use a unit cell and use a knit which is not symmetry in the both X and the Z directions? As you can see here, this unit cell is symmetry in the X and also in the Z direction. So for example, if I use this one, which is symmetry along the X axis but not along the Z axis, let's see what will happen. So let's choose input 1 and let's see the result. If I zoom in again, you can see the orientations of the unit cells are not consistent and it is not what we expected. So what you can do here, same as before, you can go back and correct the topology of the input geometry, or here is an option for you to which you can use, and if I enable this option you will have a better result. So basically what this option does is to try correct the orientation between the adjacent unit cells. And as you can see here, still there are some mismatches, but the result is much more better than before. So keep in mind that also there is an option that you can use along with the retopo option to correct the topology and the orientation of the input geometry. There is another option here which is planar. So basically you have to use this option along with the retopo option, and if your input geometry is planar like a simple grid and it has not proper topology, and usually if you have a planar object, it is better to go back and correct the topology and make a quadrilateral topology for the planar object. The next option is use image. It is self-explanatory and it assigns each unit cell a color based on the image map that you have to provide. So let me, for example, connect this box here, and let's deselect the accurate orientation, and for example let's use the previous unit cell. Let's enable the retopo option and let's connect it to a wire actually polywire node. Okay, and let's see the result, and also let's connect a facet node to correct the normal of the faces, and let's decrease the wire radius, for example to 0, 0, 2 maybe. It's too small, so let's increase it to 0, 0, 6. That's good, or maybe 0.01 is good. Okay, that's good, and let's enable the use image option. And as you can see here, it uses the default color map, the UV color.red, And as you can see here, the color of each unit cell depends on the UV of the input geometry. So if I, for example, create a UV project here, and let me use polar as the projection, you can see the result using this type of projection. Okay, that's good. Okay, that's all for this video and the version 1 of this digital asset. I hope you enjoy it, and I hope to see fantastic effects from you using this digital asset, and I hope to see you in the next video.